How do you find the area of a non-right triangle? If you have a right triangle, it's fairly easy to find the area. Area is equal to 1/2 base times height. If this were the base and this were the height, pretty easy. I can just multiply base times height because the two legs of the triangle are perpendicular to each other. So it's just 1/2 times these two legs. But if I am dealing with an oblique triangle, I have to do a little bit more work to get the area of the triangle. So first of all, I'm going to decide that I'm going to use 15 as the base of the triangle. And this is kind of handy because it's at the bottom here. I'm going to drop a perpendicular line down from the opposite angle to side AC and call this the altitude or the height of the triangle. So I'm going to call this H. In order to find H, I notice that I have a right triangle now here. So I can say, using my trig ratios, that H is the side opposite to 22 and 10 is the hypotenuse. So I can use the relationship sine of 22 degrees is equal to H over 10 to find H. So H is 10 sine of 22 degrees. So now when I say area is equal to 1/2 times base times height, I can substitute in my base as 15, my height as 10 sine of 22, and I end up with, if you put this in the calculator, 28 I got to look it up and see what exactly did I get. 28.0955. So there's my 10 sine of 22 is about 3.74. 1/2 15 times 3.74 is the 28.0955. I want to emphasize that when I did this on my calculator, I didn't round this to 3.74. I went up and copied this number, and so I didn't round at all when doing the calculations. And since I put units on here, I expect to see units in the answer, centimeters squared. Now in general, then, if I look at this given information, if I have side A or angle A given and sides B and C given, so this is my given information, or these three things here, then I can say that area is equal to 1/2 BC sine of A. And if I were given these three pieces of information, angle C, side B, and angle A, or side A, I could do the same thing. I could drop a perpendicular line down. I could say that H is equal to that sine of C is equal to H over A, and could say that H is equal to A sine of C, and I could have area is equal to 1/2 BA sine of C. And you could probably imagine that I could also do area is equal to 1/2 AC sine of B. Now that one's a little trickier to draw. Let me just show you what it looks like when you draw that. If I have a triangle like this, then my angle B is an obtuse angle. So when I draw that, it looks more like this. So here's my angle B, here's my sides A and C. So how do I find the altitude of that? Well, it turns out I have to drop a line outside, extend the base, and drop a line outside the triangle to find height. And when I find height, I need to know this little angle right here, which is the supplement to angle B. So here's B. If this is angle B, then this is angle 180 minus B. And if I find that H, so I'm saying that area is going to be equal to 1/2 times my base C times, and then to find H over A is my value that I'm given. H over A is equal to sine of 180 minus B. So h is equal to a times sine of 180 minus b. However, if you check that out on your calculator, you will find that if you take the sine of an angle and the sine of its supplement, you get exactly the same angle. In other words, sine of 180 minus b equals sine of b. So I don't have to worry about the fact that I've dropped the altitude outside the triangle. These two will always be the same. And in the particular example that we used, I'll show you on the calculator what I did here. I have to go down a little ways. Angle B turns out to be 124.18 or 124.816. 180 minus angle B is 55.1836, and I calculated the area using both angles. So there's 0.5 times 10, side A is 6.844, and I used both angles, got the same thing each time. So here's the area formula if I have, oops, I didn't mean to erase anything. Here is the area formula for a side angle side triangle. Given two sides in the included angle, you can use this area formula. You also really don't have to memorize the area formula. If you remember that you can drop a perpendicular line down and use that sine function to find that altitude, then you're fine either way. But we're going to use this and build on this particular definition then to find another useful relationship for triangle trigonometry in another video.